problem 11.83, we have this massless rod that is suspended from these two wires with the given properties here. And we want to know where we should put a weight, where along the rod we should put a weight to produce equal stress in the two wires and then equal strain in the two wires. So we want the stresses to be equal. And the stresses are going to be the tension divided by the area. So we want this to be the same for both wires. So the tension in A divided by the area of A equals tension in B divided by the area of B. Now, B has twice the area of A. So this tells us that tension in B is going to equal 2 times the tension in A. So now let's consider the torques acting about the point where the weight is suspended, which we can call C. We'll call the distance from A x. So, because we're computing the torques about point C, the weight doesn't exert a moment on it. And we have the tension at B times 1.05 meters minus x minus the tension at A times x equals 0. We know that the tension in B is 2 times the tension in A. In order to produce equal stresses. And so measured from A, we find that x is equal to 0.7 meters. Now, for part B, we want the strains to be equal. And we know that the strain is equal to the stress, which is going to be tension divided by the area divided by the Young's modulus. So setting this equal for A and B, we find that now tension B is 1 1/3 the tension in A. So our torque equation still gives us this, but now the tension in B is 1 1/3 times the tension in A. And so we end up with x being 0.6 meters.